Hi and Assalamualaikum. I am Nur Syahimah Mohammad Sedek from RS 2456A and will be presenting my final year project with title A Review on the Effect of Polymerization in Deep Eutectic Solvents toward the Properties of Polymer Electrolyte. Polymer is defined as repeating units of monomers which are linked by chemical bonds. It forms in linear, branch or three-dimensional network through polymerization process. There are two main types of polymer, including natural and synthetic polymer. Natural polymer exists in nature and can be extracted from a biological process, meanwhile synthetic polymer is commonly made up in a laboratory through a chemical process. Polymers are used in a variety of industries, including aerospace, automotive, electronics, packaging, and medical equipment. This review focuses on the use of polymer as an electrolyte in the electrochemical device. Thus, several approaches have been carried out to improve the adhesion between the electrode and electrolyte. For example, the blending of PMMA with other polymers such as polyethylene oxide (PEO), the addition of plasticizers such as polyethylene glycol (PEG), and addition of organic fillers such as silicon dioxide. Unfortunately, according to Zelanis, in 2017, these modifications were unsuccessful due to agglomeration and poor mechanical stability due to higher amount of filler and plasticizer respectively. Polymer electrolyte is known as a micromolecular system which is responsible for ion transportation and replacement of liquid electrolyte and commonly used as a solid-state batteries in electrochemical devices due to its properties such as high ionic conductivity and flexible. The usage of polymer electrolytes improves safety by preventing problems such as leakage, corrosion, and explosion. Polymer electrolyte also can be categorized into solid polymer electrolyte (SPE), gel polymer electrolyte (GPE), and composite polymer electrolyte (CPE). Next is a deep eutectic solvent. The eutectic term from the lowest freezing melting temperature obtained by mixing two or more substances that are frequently not bound to a certain molar ratio. Moreover, DES can be defined as an alternative to greener solvents to conventional solvents and ionic liquid in potential industries. These solvents has some advantages that give a good use for industries such as cheap, renewable, biodegradable, easy to prepare, and enhance the safety for batteries and supercapacitors. DES also can be categorized with two methods, which are grinding and heating. It also have four types. Type 1 is composed of quaternary ammonium salt and metal chloride. Type 2 is composed of quaternary ammonium salt and metal chloride hydrate. Type 3 is composed of quaternary ammonium salt and a hydrogen bond donor that is typically an organic molecular component such as an amide, carboxylic acid, or polyol. And the type 4 is composed of metal chloride hydrate and a hydrogen bond donor. And this is some examples of hydrogen bond acceptor and hydrogen bond donor, which can be used in deep eutectic solvent systems. Okay, next. The main problem in this study have been stated, which is there is scarce of studies on the polymerization of the monomer in deep eutectic solvent for electrolyte uses. The only study found, however, produced polymer gel, which is susceptible to mechanical instability. The significance of this study is to provide knowledge on the effect of polymerization in deep eutectic solvent to the properties of polymer electrolyte or PE. The objective is to review on effect of polymerization in deep eutectic solvent towards the properties of polymer electrolyte. The next part is literature review. In this part, the explanation will continue on deep eutectic solvents in polymer electrolyte system, polymerization of monomer in deep eutectic solvent, and followed by the characterization techniques in polymer electrolyte system from structural studies, morphological studies, conductivity studies, and the last one is thermal studies. Next is a deep eutectic solvent. The eutectic term from the lowest freezing melting temperature obtained by mixing two or more substances that are frequently not bound to a certain molar ratio. Moreover, DES can be defined as an alternative to greener solvents to conventional solvents and ionic liquid in potential industries. These solvents has some advantages that give a good use for industries such as cheap, renewable, biodegradable, easy to prepare, and enhance the safety for batteries and supercapacitors. DES also can be categorized with two methods, which are grinding and heating. It also have four types. Then for polymerization, among the available type of polymerization include free radical polymerization, reversible deactivation radical polymerization (RDRP), and ionic polymerization, ring opening polymerization (ROP), polycondensation, and electrochemical polymerization. Thus, in the study, the synthesis of polymer electrolyte by the incorporation of deep eutectic solvent during various polymerization techniques was reviewed. However, the compatibility of monomers with DES is very important in ensuring the successfulness of the polymerization. The more hydrophobic monomers, such as styrenics and hydrophobic metacrylates, frequently do not dissolve in pure DES system and require additional co-solvents. The next discussion is on categorization of polymer electrolyte in deep eutectic solvent for structural studies. Structural study of polymer electrolyte incorporated with eutectic solvent can be analyzed through FTIR. According to Kate and Panzer, 2017, their studies involving in situ UV copolymerization with the monomer used in metal acrylate and choline chloride with ethylene glycol of eutectic solvent, which shows peak deformation detected in range 1290 until 1320 cm, were attributed to final group double bond CH. Besides, the peak found at 810 cm was due to vinyl double bond CH bending. As shown in this picture, several peaks disappear from the spectrum of polymer-based deep eutectic solvent due to their association. This presents a complete polymerization in the system. Another one is in 2019 studies from Ismail, where in situ chemical polymerization have been taken place. In their studies, aniline have been used as monomer in choline chloride ethylene glycol system. In their findings, they found C bond H bending modes peak at 791 cm and 1105 cm, C double bond C and C double bond N stretching mode at 1478 cm and 1564 cm. Meanwhile, aromatic CH stretch at 2920 cm and the peak at 3000 cm related to an aromatic amines and H stretching mode. They also found OH stretching mode peak at 2586 cm as highlighted in the red circle. Then, from view of morphological studies, there are three equipments that can be used, which are optical microscope (OM), scanning electron microscope (SEM), and transmission electron microscope (TEM). In this study, Morvoid indicate its amorphicity and better electrical performance, high specific surface area, and appropriate pore size distribution, which facilitates ion penetration and diffusion. Before polymer electrolyte incorporated in deep eutectic solvent, pure polymer exhibits granule-like structures with random positioning in optical micrographs, and commonly original crystal structure of the polymer will be destroyed after they incorporated. The mass structural misalignment contribute to the creation of uneven surface as shown in the picture from two selected studies. Next, for conductivity studies, it is proved that an addition of deep eutectic solvent in polymer electrolyte system is increasing the conductivity rate. As examples, in Wong Studies 2018, addition of deep eutectic solvent improving stability and conductivity of chitosan film in deep eutectic solvent system, which are choline chloride and urea. They also stated that 1% of deep eutectic solvent to the membrane made higher by increasing the ionic strength, which then increased the rate of diffusion of species by the addition of some additives such as acid, salts, or amine derivatives. As the picture shown, where A showed the brittle chitosan biopolymer membrane without addition, and for the B is the flexible chitosan biopolymer film membrane with additional of solvent, which is more strong and durable. Next, as referred to ISIC and others 2016, techniques for determining the amount of heat needed to increase the temperature of a sample and reference as a function of time and also temperature. This is because it's related to cross-link networks upon the formation of the polymers such through the reactions, thus creating more stable structures. The Tg value of polymer films increased when DES was incorporated due to increasing in molecular weight after the reaction occurred as the tabulated data in the slide. Then, for conclusion, deep eutectic solvent has more advantages and give a good impact on polymerization process towards the properties of polymer electrolyte. From structure, it will more durable and can be stabilized with optimum amount of ion fillers. From the morphology, the pure crystal polymer will destroy and create more gaps for ion interaction, thus strengthen the conductance for the polymer electrolyte system. Then for conductivity, it will increase linearly with the amount of DES incorporated. And the last one, for thermal, the thermal stability will be achieved completely in high temperature with high amount of deep eutectic solvent ions present in the system. For the recommendation, this review only covers the effect of incorporation of deep eutectic solvent into a polymer electrolyte, with least comparing to the other conventional liquid mixtures such as ionic liquid. It is suggested that many researchers and studies should focus on the thermal properties of polymer electrolyte in deep eutectic solvent with wide range of various polymers. And that's all from me. Thank you.